those four major characteristics we have seen in the micro level. So other than that, we have some of the simple concept and the components which try to regulate the traffic flow to avoid the various transportations related problems like the congestions or the traffic, to derive that better research outcome related to the facilities what we are planning to provide, the signalized intersections or the rotary bridges, etc. So for that, we try to understand what is the concept of PCU, the capacity and the level of service. So the three concepts we try to learn, followed by what are the facilities we have provided, like the traffic signboards, marking, then the signal, the grade separated, rotary and other facilities. So all the facilities we try to cover in the basics and the macro level, and each components having the design oriented micro level understanding, how to design the rotary, how to optimize the signal time, how to fix the green time, red time and the yellow time. But all the things are coming in that master level. Probably you will be studying in your elective subject in the next semester. But before going to that micro level detailed knowledge on all the fundamentals, the macro level overview you will be getting from this particular third unit, traffic engineering. So with that objective and motivations, let me start the first component, which is nothing but passenger car unit. So what is that PCU? For the understanding, in the road, we can able to see the bus, truck, two-wheeler, LCV, HCV, the car, the different kind of that vehicle type, we can able to observe it. If we want to estimate the traffic volume of that particular road, we cannot add all the vehicle together. Say example 246 is there. So can we able to say 6? Will it replicate the exact occupations what it is happen in the road? No, because each vehicle are having the different kind of that structure, the dimensions, the characters, even the driver behavior also changing. So it is a kind of X, Y, Z and that. So we cannot add it. In that particular point of view, what we are doing in the sense, it is nothing but the weightage problem. We cannot add, right, X, Y, Z, but we can add X1, X2, X3 and all. For that, we are trying to introduce some of the weightage. For that, the standard what we are assuming is in the sense car as an a standard size, whichever is the lower, whichever is the higher than the car, the dimensions that can be given as an a weightage. Example, the two-wheeler is that lower than car. Probably we will be applying the corrections factor of 0.75 into the dimension of the car, which is equal to the one two-wheeler. So this is the assumptions we are getting. When it is coming to the buses, it is bigger than car. So 3 times it is bigger than car, that is equal to the one bus. So in the road stretch, if you are observing one car plus one bus and one two-wheeler, so we cannot say that 3. Okay, it leads to the difficult to understanding. For that, one car equal to one car only, but one bus is equal to 3 car and one two-wheeler is equal to 0.75 car. When adding together 4.75 PCU, we are giving us a unit. So this we can say that this will be the equal to when we are considering the one car, one bus and one two-wheeler. So this is an understanding we can get it. What is the passenger car unit? Excuse me. So different passenger, different car dimensions will be there for the understanding and research analysis, the practical implementations of any facilities. all the traffic, the different kind of the vehicle classes are converted to the one common standard vehicle, which is nothing but car. So that is defined as a passenger car unit. We have the different kind of that manual: Indian Road Congress, Indo HCM, Indian Highway Capacity Manual. So they have some of the what we can say, the classifications with respect to the weightage, how do we convert. So as per the IRC, two-wheeler is considered as a 0.5, three-wheeler is 1.2, passenger car is 1, LCV 1.4, truck or bus is 2.2, cycle 0.4, cycle rickshaw 1.5, bullock carts, hand cart are considering as a 2. So this is with respect to the less than 5 percentage. Example, 1000 vehicles are observed. In that 1000 vehicle, you might be knowing the two-wheeler. Two-wheeler will be the 50 two-wheeler. So when we are estimating this percentage, total volume and the traffic volume of the two-wheeler, what is the percentage? Example, this is 3 percentage, which means that you can consider as a 0.5. But example, the volume is 100, which is nearly the 10 percentage. So that time we have to apply the 0.75. So this is the way they have explained the traffic volume less than 5 percentage or the 10 percentage. What is the corrections factor to convert to the passenger car unit? But this is an old value which is replicated from the 1990 IRC manual. Now we have a lot of research outcome literature review, and many of that people, researchers defined for the Indian conditions. Also the Indian Highway Capacity Manual introduced that more suitable value for converting the dynamic passenger car unit. So with that understanding, the vehicle characteristics, the dimensions are affecting the estimations of the PCU value. Gaps, it will be the longitudinal gap or the lateral gap between the vehicle to vehicle. This is the lateral or the longitudinal. So how the gaps are there within the vehicle, that is affecting. Speed, roadway characteristics, two lane, the double lane, marking is there, median is there or not. Regulations are the control of the traffic, whether the signals or the other controls are there. What will be the environmental conditions? So all these factors are affecting the passenger car unit value. So in continuation of that, you will try to understand the major traffic flow characteristics, which is nothing but flow, speed and density. So flow is nothing but which in a given point, how many vehicle passed in the given time. Maybe 1 hour if you are considering, what is the vehicle per hour. So how many vehicle is estimated, that is considered as an flow. It might be converted to the PCU per hour also. So this is the flow. Speed, you might be knowing the space speed, time mean speed, everything we have studied in the starting of the third unit. Density, density is nothing but number of the vehicle occupied in the given stretch. It might be the square meter or the kilometer. So vehicle per kilometer, vehicle per meter. So how taking a standard trap length, within the trap length, how many vehicles are occupied. Even this can be classified with respect to the lane also, vehicle per lane per kilometer. So likewise also we can estimating. So these are the three major parameters. We have the proper relationship between this parameter also. Other than that, we have the two type of the headway. So headway is nothing but the distance between the two vehicles. If you are considering the rear to rear or the bumper to bumper, so that is considering as an headway. So this distance, that is defined as an space headway. In case if you are taking one point, in that x1 point, the first vehicle at what time it left and the second vehicle at what time it is leaving this particular point, that is considering as a time headway. So headway is basically difference between the two vehicles. If you are measuring with respect to the distance, that is space headway. With respect to the given time, that is considering as an time headway. So that is the relationships we have given, the time and the distance. This is the vehicle 1, this is the vehicle 2, and this space is considering as an space headway. And when it is coming to the time headway, and this horizontal distance is defined as an time headway. Nothing but the space means speed and the time means speed. The same concept can be applied. So these are the some of the basic and the fundamental characteristics in the traffic flow, speed, density, and the headway. And basically the speed and the flow, they have the linear relationship, that too in the negative manner. So this is the density and this will be the speed. So this is the fundamental relationships happening. When this density is increasing, the speed is reducing ultimately. So when the densities are high, then the vehicle speed become a zero, which is nothing but the jam density. The vehicles are stopped in the given corridor without moving due to the jam. So that is considering as an KJ jam density, where the density is high, the vehicles are not getting an opportunity to move. Ultimately the speed become a zero. And when we are trying to achieve the maximum speed, there is a no vehicles, very lesser vehicle, only one vehicle is moving. So that speed is considering as an a free flow speed. So this is a way we can explain the relationship between the speed and the density. At the same time, when we are trying to make the relationship of the density and the flow, so when the densities are increasing, the flow also it is going for the some maximum level. Once it is reaching the optimum, the capacity will be there. So you reached that maximum capacity. Still, if you are trying to accommodate the vehicle, what it will happen in the sense, it will reduce the flow. And when it is making the congestions and the more occupied, finally there won't be any movement, that is defined as a jam density. So basically it is a bell shape of the relationship. When we are trying to plot between the density and the flow, it is divided into the two explanations: congestion corridor, uncongested corridor. So when the densities are increasing, the flows are increasing till the optimum point. When it is yielding from the optimal point, it is moving towards the jam density, which means that at the end the vehicles are jammed in that particular corridor without any movement. The same relationship what we have studied combinedly, that can be plotted between the flow and the speed. So the same concept has been adopted here. The vehicles are moving in the free flow to the what we can say the yielding flow. That means the optimum flow capacity. This is the congested flow. So once it is going beyond that optimal flow, that is creating the congested corridor, which is ultimately affecting the speed. At the congested point, the speed become a zero. So this is nothing but your jam density also. So this is the way we can make the relationship, the three major concept we have studied: the negative relationship, density, and the speed. So this is we have a study. Then the parallelly, the speed and the flow. So this is the flow, this is the speed. So we can able to link these two graph together. So at the same time, this can be linked. This is for the density and this is for the flow. So this kind of that parallel combinations we can make it, we will try to understand it. Example, in the free flow speed, you will be getting the free speed, a free flow speed and the free flow movement we were getting. When it is coming to the jam density, we can able to project the jam density, how the flows will be there. At the same time, in the jam density, the speed will be the 0. So 1, 2, 3, we can able to link it. 1, 2 also we can able to link in parallel. So this is the first component, passenger car unit. In continuation of that, how the fundamental relationships we can make it, which is nothing but the flow, speed, density with respect to the typical curve, the fundamental curve. So how we can make it. The next one will be the capacity. So it is a straightforward term. The capacity, the road we have constructed, how much vehicle it can be accommodate. What is the number of the vehicles? So that can be estimated throughout the road or with respect to the lane, that can be estimated with respect to the distance or with respect to the given durations or in a single point how it is varying, so that can be estimated. So this level of capacity, it is ultimately giving the impact towards the level of service, which we will study in the next slide. So the capacities we have defined with respect to the three concepts. One is the basic or the theoretical capacity. The basic capacity is nothing but the maximum number of the passenger car that can be drive in that particular corridor for the 1 hour durations. During the durations, the traffic and the roadway conditions are considering as an ideal conditions. So in the ideal conditions, what will be the maximum number of the passenger car which can pass in that road stretch for the given 1 hour duration, that can be defined as a basic capacity or theoretical capacity. At the same time, possible capacity, which is nothing but the maximum number of vehicle that can be passed for the 1 hour durations in the prevailing roadway and the traffic conditions. So these are the possible, whatever the interruptions is coming, including that interruptions, how the maximum we have occupied in that particular corridor. So that is defining as a possible capacity. Then the practical capacity is nothing but to avoid all these disruptions. So what can be travel? So that is defined as a practical capacity. So basically the capacity is we can define with respect to the ratio of the space and the speed. So the spacing is nothing but the space of between the first and the second vehicle. So altogether, what will be the average spacing is estimated, that can be considered as a distance. The unit is in a meter, then the vehicle kilometer per hour. Accordingly, the capacity can be estimated. So the what we have defined in the equations, which is nothing but the space. The space is ultimately depending upon the speed of the leader and the follower vehicle. So the space is, this is the second vehicle and this will be the first vehicle. So this is nothing but space. So this space is ultimately depending upon the speed of this two vehicle. What is the type? This is the heavy commercial vehicle. This is the two-wheeler. So according to the vehicle type, driver characteristics, volume capacity ratio, other proportions of the vehicle, road geometric conditions, and the environmental factor. So all these straightforward factors are influencing what is the space should be maintained between the leader vehicle and the follower vehicle. The first vehicle is defining as a leader. The second person is considering as a follower. So this is the way we can estimate the space. Finally, the capacity is depending upon the lane width, lateral distance, shoulder width if you have a provided. Ultimately, it is depending upon the heavy vehicles like the commercial LCV, HCV and the buses. alignment, whether how the horizontal vertical alignment, the road how it is aligned, what is the intersections at grade or the overpass, underpass. So all these facilities which is occupied within the trap length, that is influencing your practical capacity. So this is the second component, capacity, the provided road, how much it can accommodate the vehicle with interruptions as well as the without interruptions, and what are the factors are influencing that particular capacity. The final component is nothing but the level of service. So basically the level of service is nothing but it is a qualitative and quantitative measures. Example, what is this level of service? You might be asking. Example, I'm telling that students, you can go and evaluate the intersections which is present in front of NIT. And I'm telling that you try to evaluate the performance from the Pavement junction to NIT Trichy. So how we are going to evaluate, and what the single way you are representing that results, that efficiency level or the potentiality of that particular road. So that is nothing but the level of service. So you might be studying about the flow, density, speed, the travel time, capacity, everything together, and you are rating A to F, maybe rank A to 6, A1 to 6. So Palpanning junction to, when I'm traveling NIT Trichy, it is performing in the F level of service. Maybe the intersection is performing as a level of service B. So what is this A, B, C, D, E and F? That is classified here with respect to the standard study. Level of service is nothing but it is a free flow. There is no traffic at all. Very low traffic. I can able to drive in the high speed. This kind of that inference you are getting while you are estimating the level of service driving as a driver, then it is defining as a level of service A. We can maintain the stable flow, but some noticeable traffics are there, then it is coming under the B. C, stable flow, traffic interactions are happening, one vehicle to the another interactions, acceleration, decelerations, give way. So those kind of the things are happening, that is defining as a C. D is nothing but remaining three are considering as an unstable flow. In D, it is a high density. Sometimes the movement restrictions are happening. In the E, the lower speed, volume is nearly equal to the capacity, very little freedoms given with respect to the movement. And F is totally, it is a congestion, no corridor, even the speed is nearing or approaching towards the zero. You have to stop the vehicle, wait, and you have to go. So this is the classifications we can give level of service A to F, and one is giving us an excellent service and F is giving the very worst service. In the middle, the variations are happening. So which categories it falls? If it is falling the B, and this will be the inference. If the road is falling under the F level of service, and this can be considering as an inference. So this is one of the measure of effectiveness parameter, how to evaluate the given road facilities with respect to the traffic movement. So this is the three major concept, the passenger car unit, capacity and the level of service. So each is contributed to understand the existing conditions of the road or the intersections or the facilities what we have provided. Based on that existing conditions, how the flow is accommodated, how the drivers or passengers experiencing the driving at that particular corridor, accordingly we can go for the future facilities. So that facilities is divided into the three level. First one will be that short term level where we can provide the marking and the signboards. The second will be the upgrade level, intersection, channelizations, rotary and the signal. Third will be the exclusive, like the grade separated bridge we are providing. So this is a three major solutions which will be improved to normalize the existing conditions with respect to the basic parameters what we have studied in previously. So the traffic signs and the markings are very simple component. During your first year introduction to civil engineering, we have covered in little bit detailed manner. So I am giving again the overview, the simple concept we will try to cover in the today's session. Traffic sign. So basically, the traffic signs we are providing to communicate between the engineer and the road users. As a driver, how I'm going to drive in that particular road. To normalize my driving behavior, how the engineers are facilities given in that particular corridor. So that communications between these two major components, it is defined with respect to the traffic control device. So basically the traffic control device fulfill the need. It is giving the more attentions for the road users how to drive it. It is easy and simply conveying the message to the driver. All the users must respect the signs. Also, the device should provide the adequate time for the users to respond it. If the intersection is there, in the intersections we cannot provide the signboard. Before 100 or the 200 meter, you have to show that the intersections are approaching. So those kind of the proper responses we have to give. So these are the need and points which we need to be keep in mind as a traffic engineer when we are trying to provide the traffic control devices to the users. So the first one is nothing but the traffic sign. It will be the color, shape one, the legend we are providing, and the different kind of the patterns also we have a given. So this kind of the communications patterns are happening, and you much aware that there is the three type of traffic signboards are there. One is the regulatory sign, the second will be the warning sign, and third will be the informative sign. The regulatory sign is nothing but it is a mandatory signboard. You must obey that particular things what it is shown. Example, stop the vehicle, uh, do not turn right or the left, U-turn is prohibited, parking is prohibited. So those kind of the information is presented in the regulatory signboard where the driver is must or obey what the meaning conveyed in the regulatory signboards. Basically, it will be the round one, and with respect to the red color outline marking and the black color inside indications we used to give. The same time we are giving the warning signs. So in that warning sign, it will be in the triangular shape where we can warn the driver the narrow bridge is there, the school zones are approach, kids crossing. So those kind of that warning informations we are driving, we are giving to the driver. So they will be little bit more aware and their attentions will be increased to react that particular situations. The final one will be the information signboard where we are giving the information for the drivers. Within a 1 kilometer, hospital is there, petrol pump is there, restaurant is there. So those kind of that information signboard, it will be the rectangular or the square shape. So those kind of that informations when we are trying to convey, so that is defined as an informative signboard. Basically, it will be the combination of white and blue. So this is the three major type of the traffic signboard, and these are the some of the regulatory signboard which give the right of way, speed indications, movement restrictions, parking, pedestrian, and other miscellaneous actions. Then this is some of the example for the warning sign: right turn, narrow bridge, railway gate is approaching, and these are the informative signboards. So this is the one facilities signboards we are providing. Then the another one is that road marking. So on the road we have the different kind of the marking with respect to the different combinations in the longitudinal directions. Two type of the line is there. One is the broken line and another will be the solid line. So when this kind of the broken line, it is indicating that it is allowing the overtake, crossing the lane from this lane to this lane. But when it is coming to the continuous, there is a no break line, but continuous line is there, which means that the lane changing behavior is strictly prohibited. So this kind of that inference we can get it from the broken line and the solid line. Also, we have provided the center line also. The center line is differentiating the traffic movement. So this is considering as a center line. At the same time, the traffic lane also provided. This is nothing but the lane. This is the lane 1 and the lane 2. For segregating this, we are providing the lane marking on the road. So when it is coming to the classifications, we have the broken line, solid line with respect to the longitudinal marking that is defined with respect to the lane changing behavior. Then the center lines we have provided to segregate the opposite directions. So this is the center line. Then we have provided the lane line also segregating the lane. So we have provided the lane line. So that lane line possibly present as a solid or the broken line. Sometimes the shoulder also we are providing the line which is indicating with respect to the parking. It will be the yellow line and continuation is there, then parking is prohibited. If the broken yellow line is provided, then the parking is allowed with respect to the edge. And these are the some of the example, the physical representations, how it is there. At the same time, we are providing the no passing zone. The overturning is not allowed. Warning zone also we are providing. So these are the later, what we can say, longitudinal what we are provided. So other than that, some of the other marking we are provided. When it is coming to the intersection, the stop line we are providing for the vehicle. So this is also road marking. Pedestrian crossing, crosswalk marking we are providing. Directional arrow we are providing. If any approaches are appearing, so that is also we are providing. Signboards we are providing with respect to the signal. At the same time, that can be marked on the road also. Parking space limit, bay 1, bay 2, bus stops or the bus bays from the road, curb marking. So all the things we can able to mark on the road to give the informations for the drivers. Finally, object marking, we can write stop. So this kind of the marking we can able to see on the road itself. So those kind of the wording message also we can able to write on the road. So I'm not sure that how many of them observe these facilities for the typical Indian condition, but I suggest that hereafter whenever you are traveling on the road, you try to observe what are the signboard we placed for the Indian condition. Try to observe the road also on road, how the marking we have provided to give the proper communications for the driver to understand about the situations which is happening, which going to happen, how to react and how to make the normal driving behavior, which ultimately avoiding the accident between the drivers. So with this detail and the more component of the today's sessions, we will wind up end the sessions here. Today we covered three major concepts: passenger car unit, capacity, and the level of service. which giving the evidence of evaluating the existing conditions of the road network, followed by the simple facilities, traffic signboard, three major type, and the different kind of the road marking, longitudinal and the traverse marking, and the word marking, how it will be there. So that concepts, the classifications, how it is making the communications between the road users, so that we have seen in the macro level. So the concept, three concept, we have much detailed study in the next semester traffic engineering and safety with respect to the design and with respect to some of the problems also you are going to study in little bit micro level. So with this detailed understanding, so I will wind up the today's sessions, followed by we have the two major component, grade level and grade separated level. Probably within a one lecture, I will wind up this particular component where we will end our lecture of 3 units in your CEPC20. So we'll try to cover the next Monday, else the next to next week we will try to cover, and we will try to wind up our session of this particular semester. So any doubt from the today's session? So today it seems that it is a heavy, but the concepts, the category what we have studied, it is only the four only: TCU, capacity, level of service, and science road marking. So this is the four component. Probably you go through the videos, so you will be getting one more time if you're recollecting the things what we covered in the class. That will be strengthen your knowledge in the concepts. Okay, if there is no doubt, we will end today's sessions. Probably we will meet and we will try to wind up in the next sessions, maybe within a week, with next week or next to next week. So thank you everyone. Stay safe. See you.
Thank you, sir. Thank you, sir.